Hello everyone. Thank you for attending today's Watershed webinar, Energy in the Bay Watershed, a Changing Landscape. My name is Michael Sell, Director of the Institute for Energy at St. Francis University, and today's presenter. Let's get started. And now I'm going to turn it over to myself. So, if you haven't heard my background before, just a little bit about me. I've got my education from here at St. Francis, both a BA and an MBA. And as an undergrad, I studied the history of wind in Pennsylvania, and I'll discuss that a little bit in the session today. And during my time as a student, I also worked with what was the Renewable Energy Center, doing communication, outreach projects, education. And that eventually turned into a full-time job here, and I've been here since 2012, involved with various outreach initiatives through the energy program, as well as other science outreach initiatives, including NOAA BWET. So about the Institute for Energy, we have been around since 2005, and the program got started in the wind field doing site assessments for farms, small businesses, homes, and you can see back there some turbines that we collected data for, and we'll talk about that as well. We've conducted energy research on various topics related to Pennsylvania energy issues and have done community outreach. So that includes seminars, tours, school visits, and other initiatives to educate the community about energy. So for today, we're going to look at the past, present, and projected energy use of the Bay region, look at traditional energy sources, some of the newcomers to the energy scene, talk about some resources you can use in your classrooms, and answer any questions you may have. Now, you're probably all familiar with the energy sources that exist, but just as a refresher, we've got the non-renewables. Things that are fossil fuels include coal, natural gas, and oil, as well as nuclear. And then the renewables, so biomass, geothermal, hydro, solar, and wind. So I can't go back super far in time. I'm not sure that the data is quite as solid when we go back too far, but at least we can go to the year 2001. And I'm going to pull up the poll question here. In 2001, what was the largest source of electricity in Pennsylvania? So was it coal, natural gas, nuclear, or wind? And share the results. And y'all got it. Very good. So coal was king back in the day, just about 20 years ago. It accounted for about 57% of our electricity generation. Nuclear, about 38%. And so between those two, they made up the bulk of electricity generation here in the state. Things like petroleum, natural gas, just tiny percentages, and renewables barely showing up on the chart. Wind just 0.01%, solar, nothing really notable at all. Comparing that to the United States in 2001, coal, about half of our electricity generation, similar to Pennsylvania. It was a bit different with nuclear and natural gas, Pennsylvania favoring that nuclear area, natural gas more so in other parts of the country. But you can see wind and solar, very tiny percentages there. Looking at oil, the resource here in Pennsylvania specifically is mostly west of the Chesapeake Bay watershed. You can see the blue outline here where the Bay region is in the kind of central and east central part of the state. And most of what had been developed was to the western side. Historically, Pennsylvania, very much a oil-rich state. Top producer, of course, the first commercial well drilled in Titusville, and a lot of production back in the day, but now we are 17th in the nation for oil production as of December 2022, according to the Energy Information Administration. And if I reference the EIA, the Energy Information Administration, or it's the EIA where a lot of the data has come from today. Oil is being taken out of the ground and used primarily for fuel, transportation fuel. When we look at coal, as was referenced there in 2001, a lot of coal being used for electricity production. Most of the coal-rich regions, again, west of the watershed, but some of the areas, northern Cambria County, Clearfield County, and some of the Scranton area over to the east, some really rich coal seams in the state that fall into the Bay watershed. Of course, we can get coal out of the ground by either clearing off the land on top, moving away the soil, or going down deeper into shafts and drilling out that mine, coal from the mine. And with natural gas, that's really become the talk of the town the last 15 or 20 years. The green area would include the areas that are in blue. That is the basin where gas is primarily found. The blue area is the play where the production is primarily occurring. And you can see that the watershed does overlay a decent amount of that area. This has involved pulling gas out of the ground through hydraulic fracturing primarily as a big producer these days. So in conventional gas drilling, you can see on the left side here, they were going straight down into the ground. On the right-hand side, you've got unconventional drilling. And so hydraulic fracturing, they use a lot of sand, water, some chemicals, and they're able to crack open that gas-rich shale and extract the gas from that. Now, when we're talking about watersheds, this can be a highly intensive use of water. And so that can be upwards of 9.7 million gallons of water per well in some statistics that I saw. As little as 2,600 gallons for some of the real small facilities, but a wide variety in water use there and often over 1 million gallons per well. Now, when we use fossil fuels, there are some consequences from using them, and we could run out if we continue to go on this path. Of course, they lead to air pollution, including greenhouse gas emissions, and there can be environmental impacts associated with their resource extraction. So in the pictures here, you can see we've got acid mine drainage from an old coal site, and then there's, we can also end up with air pollution. From a climate standpoint, temperatures are rising, and electricity production from fossil fuels is a contributor to putting more greenhouse gases in the air and warming up the planet. And this has an impact on the Chesapeake Bay. As noted here by the Chesapeake Bay Foundation, each year more than 85 million pounds of nitrogen pollution, about 1/3 of the bay's total yearly load, comes from the air, often from burning fossil fuels, of course, cars and power plants. And you can see that the airshed kind of extends beyond that of the actual watershed. But this can have impacts on the water and carbon dioxide entering the water as well. So the Maryland Ocean Acidification Action Plan from 2020 notes that atmospheric carbon dioxide is a key driver of acidification, accounting for about half the occurrence of reduced pH in the Chesapeake Bay. And so ocean acidification, and also in these smaller bodies of water, is becoming a problem, particularly for some of the shelled creatures who live in the water. As the waters become more acidic, the CO2 can dissolve their shells, and make it harder for them to create them or have them in the first place. But we do have some alternatives, and I want to start off with a couple of the traditional sources that have existed for a good while now that we've been using, like nuclear. So some advantages of nuclear include that it's carbon-free, and it has a pretty small footprint with a high output. So you can produce a lot of energy on a small site, and it can work day and night. But some disadvantages include that it's not renewable, expensive to build and operate, and you end up with nuclear waste. And of course, if you have a failure, that can be super devastating. So nuclear is working by splitting apart a uranium atom in a process known as fission. New technology is looking at fusion, which is smashing things together, I believe. And you can see here in the middle, there's kind of a diagram. Basically, they're using the energy, the heat, to create steam by boiling water to spin a turbine that will generate electricity. And with hydropower, hydro is a renewable. It can be cost effective once the facility is open. So over the long run, viable resource. It's produced domestically and it can work day or night, but does have that high upfront cost to build, very location dependent, and it can have an impact on wildlife, notably fish, and being a barrier to migration. For those who are teaching the younger grades, the water cycle is certainly relevant. And so when you have the sun come out, you can evaporate the water, and then it's coming back down into lakes and streams, and we're able to then capture that movement of water and the flow of water to spin a turbine to generate electricity. Here's a map of the Susquehanna River from the PA Fish and Boat Commission. And there are 4 dams located between Harrisburg and the Chesapeake Bay. And at those sites, they've installed fish ladders to allow the fish to flow back upstream. This particularly applies to shad, I think it said. And this allows them to overcome those barriers, but that is a challenge for wildlife. And then with the Conowingo Dam, that's kind of a last stop for the flow of water before it gets to the bay. And a lot of nutrients are getting built up behind it. And so there's debate as to whether or not it needs dredged. So that is a concern there, but it is producing a lot of electricity. So there's kind of these pros and cons with each of the energy sources. So let's jump ahead now to more current day. And I'm going to bring up the second poll question. In 2021, what was the largest source of electricity production in Pennsylvania? So we got coal, natural gas, nuclear, or wind again. All right, so we've got natural gas here as the highest vote, and that turns out to be the correct answer. Yeah, so we have definitely seen a change over the last 20 years. So rather than coal being king, natural gas has really become king. Over 50% of our electricity production now comes from natural gas. Nuclear hanging out there in second place, right around a third, and coal around 12%. We have seen slight changes in those other categories, but still pretty negligible compared to the 3 non-renewable sources here that make out the, oh gosh, what, over pretty much 90%. Wind is now the largest renewable. It has surpassed hydro, biomass, and solar do appear on the chart here. And other and petroleum round out the chart. For the United States as a whole, natural gas is also our largest producer, but coal and nuclear hanging out there around 20% or so apiece. What you'll notice that's different in the United States as a whole compared to Pennsylvania is that wind has grown to be about 9.2% of the electricity, and solar is showing up there just under 3%. So there has been growth, even if it's not so much here in Pennsylvania. If we were to look at this chart between those two 20-year spans in a different way, the EIA looked at this recently in a post that they did on their website, specifically for Pennsylvania. You can see how natural gas has grown and the share of coal has really diminished as plants have closed and the newer, more efficient gas plants have come online. If we looked at power plants in the United States as a whole, you can see that they are spread pretty widely all over the country. More specifically here into the Bay Watershed, I believe these are sites that are over a megawatt in scale. And you can see that they're scattered throughout the region, more notable down in the Maryland area in the Bay region. And these sites are about 425 of them. They're split up here, with solar being the most number of plants, followed by natural gas, biomass, petroleum, and wind. Now this is by number of plants. So if you were to count, one plant here to one plant here, that's different than saying how much electricity they can produce. So if we look at this another way, by their installed capacity, natural gas is the clear winner here. Close to 27 or so thousand megawatts of electricity generation capability, followed by nuclear and coal. This reflects the chart from earlier about with Pennsylvania more so, and you can see that the production is stronger here. So when I'm talking about capacity, different sources have different capacity factors. And so capacity is going to be the maximum power output that you could have from an energy source. So if a power plant is running 100% of the time throughout the year, that would be 100% capacity. So nuclear plants on average in 2021, according to EIA data that I got from the Department of Energy, shows that nuclear is around 92.7% of the time they were operating. Geothermal, pretty high. We don't have any of those plants here in Pennsylvania. Natural gas and coal hanging out around 50%. And then some of the renewables, hydro, wind, and solar between 25 and about 38%. So you can think about with a wind turbine, when the wind isn't blowing, you're not getting any production. There's the reduction in that capacity. Now, even though wind is only around 34.6% of potential capacity, they spin about 80% of the time on average, but they're just not spinning at full power. And with solar, of course, at nighttime, that reduces their potential and when it's cloudy and things like that. Looking ahead to the future, the PJM, Regional Transmission Organization, they're the ones that coordinate the movement of wholesale electricity in different states in this region, as well as DC. You'll notice that this looks nothing like the pie charts we looked at before for generation that already exists. We're not seeing coal here, we're not seeing nuclear here. Most of the proposed technology is solar, wind, and battery storage, or a combination of those, along with maybe some natural gas or hydro. But as we move into the future, there's a real wholesale change here in the types of technologies that are proposed to power the grid and expand that use. So there are certainly environmental reasons for that. A lot of the wind and solar are considered to be cleaner, less polluting, but there's also an economic side to it. And so this chart from Bloomberg NEF shows that the levelized cost of electricity has really declined in most cases for solar and wind. The exception right now still being offshore wind, so putting turbines out in the ocean or in lakes. That's still fairly expensive. Costs have come down there. So that's the blue line, the light blue line up here. If you can see my mouse, which maybe you can't. But let me see here. Can I do laser pointer? There we go. This blue line, that is offshore wind. But you'll take note of this blue line here, onshore wind, turbines that are built on land. The cost has gone from about $93 back in 2009 down to about $46 in 2022. For solar, the drop has been more dramatic, from around $300 down to about $40 to $45 per megawatt hour of electricity generation. And so these are the large scale plants for putting it on your home, solar panels on your home, or a small wind turbine. This isn't factored in quite as much. The costs have still come down, but on the large scale, they're really competitive and probably even cheaper than gas and coal. So you can see here. So the black and gray lines, the cost, if anything, has held steady or even increased some. And in the last year or two, there's been a lot of supply chain issues. So a lot of these sources, regardless of what they are, have gone up. But comparatively, solar and wind are still cheaper on a large scale than the fossil fuels. You also notice battery storage here. Prices are coming down on that, but they're still fairly expensive compared to the alternatives. Looking now at wind energy, some of the advantages include being pretty cost effective, supporting local tax base and landowners, being clean, renewable resource, and a domestic resource that we can produce here in the local area. Disadvantages include being a high upfront cost to build the turbines, location dependent, having visual and sound pollution, impact on wildlife, and intermittency. Of course, you can't predict too far into the future whether or not you're going to have a specific amount of wind. Parts of the turbine, how they work, the wind is being caught by blades, and that's going to spin the turbine around. All the gears and mechanics are located in the nacelle. That's where the blades connect to. And they are sitting on the tower. The tower gets the turbine up into the air. The higher up you go, generally, the more wind energy you can get and extract that power. I like to note that a fan works the opposite of a wind turbine. So a fan is going to use electricity to create airflow, whereas a wind turbine is going to use airflow to generate electricity. So they work the opposite of each other. Now, wind has actually existed in Pennsylvania and throughout the United States for a long time, primarily for pumping water, grinding grain, but there even were some electricity generating windmills for at least 100 or so years. And Pennsylvania, at various times, was home to windmill manufacturers, particularly from the mid-1800s through the 1920s. And here are a couple example brands that were available. And you can see the Bosman wind energy patent for a pretty unique design over there on the right. And when I was doing my history project, I found that he was even selling these to, or at least had an advertisement in a newspaper in New Zealand. So it seemed like he potentially had a pretty far reach. I interviewed a gentleman in 2009 named Jerry Sharp, who lived in Loretto near campus, who remembered a windmill on his grandparents' land on top of a coal mine where his grandfather worked in Crescent. And he said that they had cut the top off of a tree and set this on top of it with a tripod. And you can see over here to the left, he drew a diagram of the machine. They cut the top right off the tree. All right, and that's where they put the tripod. He said the blades were probably 4 feet, 2 feet apiece, and it didn't take much wind to move it. And they had 2 wires running from it into the house, into the living room. And they had a dresser in there, and in the bottom of the dresser, they had 6-volt dry cell batteries and a voltage generator. And he said there was no 6-volt light bulb, so they took the reflector out of a headlight of a car with the bulb in it from the headlight. Wasn't the brightest thing in the world, but it showed light. And he used to sit there, and the lights would keep getting dimmer and dimmer and dimmer, and then eventually would run out of power from the batteries. And I know he also told me that they could pick up KDKA with a radio, but it was pretty scratchy. But a pretty interesting story. And so even though we think, that wind is kind of a newer technology, and it certainly is on a large scale, it was used in the past. One of the reasons that it disappeared for a while was that the power lines came through in more dependable, consistent service, favored just having the lines come through. When developers are looking where to put turbines, the annual average wind speed is very important for a specific location and height. At St. Francis, we have maps on our website, and we can actually zoom in pretty close to a specific spot and determine, what the expected speed might be. With this map here of the state, the blue areas are going to be where the strongest wind resources are. You'll note that they very well correlate to Lake Erie, as well as some of the higher ridges of the southwest central part of the state, as well as the northeast corner of the state. And if we were to plot the turbines that are in the state, they correlate very well to those windiest areas. In current times, there's 26 wind farms, about 750 turbines with a capacity of 1,459 megawatts. So my question for you now is, what exactly would a 2 megawatt wind turbine power? How many homes? So here is your next poll question. Could you power 3 to 5 homes, 30 to 50 homes, 300 to 500 homes, or 3,000 to 5,000 homes? And a 2 megawatt turbine is pretty average for what you would see in this area of Cambria, Blair, Somerset. All right, thank you, everybody. And here are the results. So 3 to 500 is a good average. Per megawatt, somewhere around 225, 250 homes. And so a lot of the turbines are 2 megawatts. If you think of the ones above Altoona, if you're familiar with those, some of the ones along Crescent, they're in the 2 megawatt range. Towards Tyrone now, in northern Blair County and southern Center County, they are working on installing some turbines, and I believe they are upwards of 4 or 5 megawatts. So the amount of power they'll be able to get out of those with fewer turbines, bigger blades, will be significantly more. And some of those can reach upwards of 600 feet, I believe. Here at the university, prior to my time, and they had done some data collection at various sites. I guess actually I was involved in setting up the tower that's pictured here. We don't do any on-site data collection anymore, but there were various sites throughout the state where we'd put up 200-foot tall towers, find out what direction the wind was blowing from, how windy it was from a speed standpoint, for the period of 1 to 2 years to get a good idea of whether or not this would be somewhere where commercial turbines could be placed. And so what was unique with this program was, rather than a developer coming in and saying, hey, to a landowner, can I use your land? This would allow the landowner to go to a developer and say, hey, I have a good resource. Would you like to develop my land? And that was a unique proposition from this project, and actually resulted in 4 of the wind farms in the state. At least the data being incorporated into them. We didn't develop the projects. When we look at future wind development, Those highest wind areas pictured here in the blue areas of the map, a lot of that resource overlaps with public lands. So state parks, state forests, as well as the Game Commission's lands occur at the same location. So a lot of those higher elevations, there's an overlap. And they're not areas where development is allowed. And I'm not saying there should be development there, but oftentimes when there are calculations done that say Pennsylvania has X amount of wind resource potential, this may not be considered in those calculations. In addition, some of these blue areas are already developed. So about a third has already been developed of these blue areas. A third isn't developable because it's public land. And that leaves about a third of the land left for potential development. So when we're looking at wind as a technology being a lot of production in Pennsylvania in the near future, probably not. If the technology continues to grow and improve where it can be in lower wind resources, then you may see additional development. But right now, it doesn't look like there's going to be a ton of development occurring. Some of the things that are considered for wind development include transmission lines and where to place them. Oftentimes, high wind sites aren't near high population centers, so you need to have transmission lines installed or connect into to build a wind farm. Certainly, the proximity to buildings, roads, and people is accounted for the, some people like to look at turbines, others think that they don't look so nice. You can have ice throw, sound, and shadow flicker. So these are all things that need to be considered. One of the nice things with wind is once you've installed a turbine, since they can't be near buildings, they actually preserve that land then, so nothing else can be built there. When we look at land use, you can see from above here, over to the left, some reclaimed surface coal mines where turbines have been installed. So that, seems to make good sense. Now the turbines over to the right have gone through a forest. And so from an environmental standpoint, maybe not as good of a choice. And so these are things that need to be weighed with our energy usage. And then on the right is some agricultural fields. If you take a look there, when I took this picture, I didn't even notice this tractor, this giant tractor, but it's down there at the base of these turbines, and you can just kind of get a sense of the scale, how big they are. One of the things that comes up from an environmental impact that's negative with wind is the impact to birds. So about 4 birds per year per turbine are killed, primarily songbirds, occasionally maybe a raptor. No documented eagle kills at this point, thankfully. But the bigger concern is actually bats. And an average of 27 fatalities per turbine per year occur. So this is one of the big challenges with the wind industry right now. A lot of research going into figuring out how to prevent the bats from coming to the turbines. For some reason, they seem to be attracted to them. Researchers know that they like to fly to the highest thing in the forest, generally the highest tree. They like to roost there. So it could be that they think that the turbines are the best place to roost. It's unclear. But one of the things that has been done to help protect them is to not run the turbines, particularly in low wind nights from about spring to early fall timeframe, roughly in there. The bats like to fly when low wind speed. Those are times when there's not much production from the turbines. When the wind picks up, the bats aren't out flying and the turbines can produce electricity. That has shown to produce a significant reduction in the amount of impact on the bats. But research is ongoing. And with white nose syndrome, there's still a lot of uncertainties with populations and the impact that is having. Let's take a quick peek at the construction of a wind farm. This is the Patton Wind Farm. Here in northern Cambria County, you can see the St. Francis. We're here near Ebensburg. If we zoomed in, each of these green dots with the stars is one turbine. There's 15 in the project, so it's a 30 megawatt project put together in 2012. And you can see that it pretty well correlates with those blue areas, the highest wind speeds. They're throughout farm fields along Route 36. It's the west of Patton. So a lot of earth moving to begin the project. Cement poured, can get the scale there with the four-wheeler. A lot of steel goes into the ground. And these images are a credit to Marty Honor. He was pictured in this picture here. He provided these to us during the process. He was involved in a lot of the on-the-ground work and working with the community and getting the landowners together for this project. He's a local farmer. The crane has to be put together in various pieces. It's trucked in, and they are quite expensive to operate, thousands and thousands of dollars each day. For this project, they installed a new substation to send the electricity to the grid. I like to tell students when I'm talking to them that this picture looks like a little toy set, but in reality, it's quite ginormous. The nacelle, which is sitting back there on the trailer, that big white piece, is actually the size of a small school bus. So these are very large machines. The blades can be over 100 feet long. One of the challenges of moving them or having larger turbines is, the constraints of getting them into place. Here we can see them continuing the work on it and the finished product. There's a great little pull-off with a pavilion if you're ever driving on Route 36 in the Patton area, where you can stop and see the turbines. Wind production varies throughout the year, so you're going to see the highest amounts during the winter time and a decrease in summertime. So this is a really good pairing with solar because, of course, solar is going to have more production during the summertime. Here's a view from underneath a turbine. Looking up through the tower, there's usually a ladder in there, electricity conduit coming down, and in some cases there's an elevator in there to get materials and even possibly personnel to the top of the tower. There's usually some different landings there in the different sections of the tower. From the top, this is a picture from Allison Rohr. She used to be director here at the center, and she used to climb and work on the turbines. And so you can see the data analysis equipment up there, the lighting system, and some of the view of the top. And here, this isn't in Pennsylvania, but you can see the view from the turbine here. Certainly, I think some people might find that to be an exciting venture, and I'm not so sure. I may just keep my feet on the ground. When we talk about life cycle energy and what it takes to put the turbine together versus what it generates, it's estimated to be less than a year's worth of the turbine's production for the construction process, the operation process, and eventually decommissioning the project. Average lifespan estimated somewhere around 20 to 30 years. Most of the turbines recyclable, somewhere around 90%, primarily steel. The blades right now are the primary concern, but there are new methods being considered and deployed to make it that they're more likely to be recycled in the future. Some examples of innovative uses that have occurred in Europe include making bridge out of a blade and kind of artistic chairs. And in the real recent times, there is a company now that is figured out how to shred up the blades, and they're going to try to reuse them and the fiberglass that's in them for new purposes. So rather than landfill the blades, it does appear they may get a new lease on life. Overall, we're seeing that blade size, turbine size as a whole getting larger, both onshore and offshore. And sometimes I feel like maybe I say more negative things about wind than positive, but I do just want to note that wind turbines spin without having anything needing to burn. And we'll take a look here now at solar. Solar has a lot of advantages from a cost effectiveness standpoint, at least for large scale systems. Again, it can support local tax base and landowners, clean renewable resource, can be produced, the production can be produced domestically. It's quiet, doesn't have any moving parts. One of the real benefits of this technology is that it's modular, so you can have lots of different applications for it. But it does have a high upfront cost. It'll only work in shade-free areas. Of course, there's the intermittency with shading. Visual pollution, if you've got large farms, might not be the most attractive thing to look at. And it's a low energy density, so you need to cover large areas to get a lot of production. Starting out with the basics, just having passive solar technology. So if you think of a greenhouse, you can have sunlight come down, come into the greenhouse, get trapped, become heat, keep these flowers nice and toasty. During summer camps, we've done melting marshmallows, making s'mores. So you can see here, we've tested out white and black areas there to melt the marshmallows. Which one will do it faster? Which one gives you a stickier marshmallow? So just a fun little experiment there. My final poll question for you is, for this whole system here, you can see two different ones. The one over on the left has cover with a lot of water heating panels, and on the right, you can see them on the roof of the building in the background. And so they're actually able to heat water to then help heat the swimming pool. And my question for you is, where is the location on the right? The swimming pool to the right. Is it the house featured in Home Alone in Chicago? Is it at the White House, Taylor Swift's mansion in Nashville, or the Holiday Inn Express in Greensburg, Pennsylvania? All right, thanks everybody. So I managed to, I mean, I know it's a complete guess, but it actually turns out that it's, none of you got it. It's actually at the White House. So this system was installed when George W. Bush was president. And so they were looking at a more efficient system. And so that's one of the technologies that's actually be used from a government standpoint. But so moving on, here we have an image of a home, south facing. You can see a lot of windows there, so we can allow sunlight to come in, heat the home naturally without a lot of energy use. And you can also see the water heating solar panels there to heat up the water. And rather than doing that with some other technology, maybe something to supplement it, but just using the sunlight to heat water can be an effective use of this technology. Solar panels, their basic structure is a cell. If you put cells together, then you have a panel, or what they refer to as a module. If you put a lot of panels or modules together, you get an array. And if you put many arrays together, you end up with a solar farm. So pictured to the right is the Keystone Solar Project, which at one point was the largest in the state. It covers about 30 acres and can power about 900 homes. Solar panels work with the sunlight coming down into them. In the metal contacts, the photons of light strike the panel. They knock an electron out of place and eventually create a circuit, and the electrons flow in that circuit, and we can create electricity at its basic description there. There's a positive side and a negative side to that panel. Some areas where solar is used here in Pennsylvania include the Crayola Crayon Factory. So if you've got students who are using any of their products, oftentimes it will say that they're renewable powered on it. That's that top left picture. The Pocono Speedway, as well as the Philadelphia Eagles, have a lot of solar panels. There are some examples there of streetlights on a barn. The middle picture down in the bottom is actually the Carlisle Area School District. If you're driving along the turnpike, you may see them off to the side there, and they're powering a lot of the schools with solar powered. And then in the bottom right, I'll often ask this as a trivia question. There's actually a second use of solar at the White House. And so when Barack Obama was president, there was electricity generating solar panels put on the roof. And so you can see the Washington Monument out there in the distance. An interesting technology being used in the Bay is Mr. Trash Wheel. And so you can't see his eyes because I think it's on the other side, but there's a decent amount of trash that will enter the bay, particularly the inner harbor during storms. And so they were looking for a way to clean up and collect that garbage. And so this device that I believe the gentleman picture developed will actually capture the trash, and they're primarily using water power. And you can see the wheel there, but they're using solar power to supplement that to, as the pollution comes past the device, it'll pick it up and put it into a trash bin, and they're able to save that from ending up going through the bay and out into the ocean. This technology is being deployed in 4 locations in the Baltimore area, and there's a lot of interest. I just saw that they've now have had interest from all 50 states to use the technology to clean up rivers and keep pollution from getting too far downstream. Here on campus, we have the Mobile Power Lab. On the roof, we've got a 1.68 kW system. So average house would be about a 10 kW system, to give you some perspective. This little unit was built to showcase different sustainability technologies and also show how solar could work. It's got battery backup, a biomass pellet stove, and insulation in the walls, various technologies. Up on the space station, astronauts using solar power for their life support systems and experiments and a lot of the things that they do. If we looked at the surface of the Earth, the Land Art Generator Initiative found that by 2030, all the use that we would need, including transportation, could be met with the square down in that bottom left being covered in solar panels. Or if you spread it out over these dots throughout the world, that could meet all of our needs just with solar alone. I calculated that that would come to about covering Pennsylvania 4.2 times in solar panels. Fairly decent area, but when you look at the land mass as a whole, not too large. And the technology does exist to do that, should we put our minds to it. Pennsylvania has a plan to increase in-state solar generation to provide 10% of in-state electricity consumption by 2030. And the Chesapeake Bay Foundation is fully supportive of solar power as an essential part of reducing emissions from fossil-fueled energy production. Cutting emissions not only combats the urgent threat of global climate change, but also reduces harmful air pollution that contributes nitrogen that pollutes local streams, rivers, and the Chesapeake Bay. And one of the challenges with solar is, of course, covering up a lot of land. Oftentimes, the prime locations, these cleared areas, is prime farmland. So a new term, agrivoltaics, photovoltaics is the technical term for solar panels. Mashing together agriculture and photovoltaics, you get agrivoltaics. Looking to grow plants around them is kind of an up-and-coming research field and possible use for kind of coexisting between energy generation and producing food. Some plants prefer to be in the shade, and so there could be some real benefits here. They also have been using sheep to clear out the weeds around these instead of having to mow. If we looked at the greenhouse gas emissions, bringing this all together for different energy sources, You can see the chart here up and down. The higher amounts, more greenhouse gas emitted. Most of the renewables pretty low on the scale there throughout their lifespan, with the natural gas, oil, and coal over on the right there a lot higher, as you would probably expect. Project Drawdown, if you're interested in looking at potential solutions to climate issues, wind and solar have been found to be some of the best ways with current technology to reduce our carbon emissions. Energy storage, definitely an up and coming piece that will be useful for pairing with wind and solar so that we have electricity that's stored for when we don't have those working. And a study from Oxford University last year found that making the transition to a rapid green energy system would result in trillions in net savings. So I just like to note that energy conservation and efficiency is important here. The only source of energy that has no consequences is that which is not used. Some resources include EIA Energy Kids, great website there. The National Energy Education Development Project. They've got good curriculum, activities, various things available. Kidwind, there's actually a state challenge you can go to that is, this year's challenge is tomorrow for Pennsylvania. But they have materials where you can build wind turbines and solar panel activities. Here's a couple of examples of those in action. And at the Institute, we have the wind maps, as I mentioned before. We have a clean energy survey report that we did a couple of years ago looking at the future of energy. Our public lands paper is available. And so looking at the future, solar, energy storage, electric vehicles, which I haven't even touched on, possibly hydrogen, small modular nuclear reactors, various things that could be coming to the Chesapeake Bay region. But with that, I know I'm running out of time here. Are there any questions? Thank you for attending today. So, question about how much energy produced in solar or wind go to the local community where the plant exists. So generally, the plant is going to be tied into the grid through like a substation, as I showed with the wind plant, and used locally. General rule of thumb with the wind plants, I was told, is about 80% was used like within the real close area. With one of the wind farms, I think there is a direct line from Johnstown to like New York City, but generally the electricity is going to be used close to where the plants are. It wouldn't be physically, the physics doesn't work very well for the transmission lines to run to California for stuff that's generated here. And then the systems in California to generate for here. So it's mostly local. If you're near, say, a wind farm or a solar plant, it's probably going to be used in that area. It does depend where the lines are running. And because the grid is interconnected with all these sources, we can't say for sure which source is powering it unless you have just that one direct line, like say having solar panels on top of your house. Where there might not necessarily be a community benefit is that, say, a company from out of state is purchasing those credits for that system or owns that operation. And so they may be benefiting from that and it wouldn't reflect in your bill, if that makes sense. And for the batteries and non-renewable parts, certainly a concern. Certainly in the extraction process, there's a lot of rare metals and materials that are used. So I was looking, the amount of solar panels that are going to be produced and then come to the end of their life by 2050 is going to be pretty significant. Right now, there's not a ton of them being used. So there's not really a lot of recycling occurring. But as there are more and more of them available, the market should be there to try to recover that stuff because it's very valuable material. So certainly concern for getting in the water, some of the contaminants for leaching out, for the stuff that doesn't get reused or ends up in a landfill. But you know, if we keep burning fossil fuels, there's also the extraction and the materials that come from that and things. So it's certainly a balance. So definitely try to emphasize the energy efficiency of things. Well, with that, if you have any more questions, feel free to reach out to me, and I appreciate you participating today. Yes, thanks for coming.